away.
I keep turning it on and off. It's playing up now. Oh, there we are. I'm back on.
Okay, here we go again.
Are we back
We're
running?
sorry, we're back on the air. We lost Lawrence, and then he was blocked from rejoining the show. So we had to start a new hangout. And gosh darn technical difficulties. It sounds like somebody's trying to block what we're doing. I mean, I'm just getting to be the point of paranoia. So that's really sad.
I think somebody is trying to block us. Anyway, as I was saying before.
All right, take it away.
You've got twice as much longitude as latitude. So I was thinking, you know, a ratio of 2 to 1, and maybe the Earth is twice as wide as it is high. And I took some measurements across 10 degrees, 20, 30, 40, 50, 60, 70, 80, 90. And went on this calculator and got the distances and plotted them all out, joined up the dots, and it made the perfect diamond shape. So if you're going to do this hangout and join in, or you can just watch it if you want, you'll need a pencil, a ruler, 12-inch ruler with centimeters on ideally, and ideally an A4 piece of paper. I know you Americans have different size pieces of paper. And the first step is for this piece of paper, you need to find the dead center of it. So what you need to do that, and now you probably think I'm not trying to say you're stupid or anything, but I'm just catering for the lowest common denominator. To find the exact center of this piece of paper, or the one that you've got, you need to measure across the top how many centimeters it is, okay? And this one's 29.8, so it's 14.9. So measure your paper across the top, the widest bit, okay, and then find the halfway distance, and take your pencil and make a little mark on it, and then go across the bottom and make another mark so that you've got 2 marks, and join the marks up with a line. And when you've done that, do the middle bit, sorry, the side piece, find the halfway down, mark it with a pencil, find the other halfway down, mark it with a pencil again, and you should have got a square across the middle, you know. Or,
okay,
you know.
Let me interject here, because you've done this before. You're going to end up with 4 rectangles on your piece of paper. You're going to have a line down the middle and a line across the middle, both horizontally and vertically. And you're going to end up with that piece of paper in 4 quarters. Okay, go ahead, Lawrence.
Okay, so once you've drawn your 4, you know, your lines down and across, where they intersect in the middle, that is going to be 0 degrees everything. 0 degrees latitude, 0 degrees longitude. It's going to be bang dead center in the middle of this diamond-shaped Earth. So first of all, we're going to construct the diamond, and then we're going to prove that that is correct. So the scale that we're going to be using is 1 centimeter is equal to 1,000 miles. So first of all, we need to find out how far it is from the center to the North Pole, and the center to the South Pole. Well, they're both the same, and you can check this out to vary yourself. I'm not going to do both. I'm only going to do one, but we'll do some others later, which will cover the south side. So you need to go on to a longitude and latitude calculator to find out how far it is. So I'm going to
and I put those links to the calculator and everything else we're going to be using in the description box of the video. So go there, and those are live links. You can click right on them and open the pages that we're going to be working from.
Okay, so I'm going to just get this screen share if I can. Google Hangout. Screen share. Oh, we got it now? Yeah. Do we have it, Laurie?
Yes.
Okay, so first of all, we're going to find out the distance between bang center in the middle of your piece of paper where you put where the crosses intersect, and we're going to find out the distance between that point and the North Pole. Now, I've already typed these in. We've got 0 degrees north. So if you've got this link on, then it's 0 degrees north. So you put a 0 and an N for north, and 0 and a W for west. And then we're going to go from 0 degrees north. So you're going to 0.2, the second one down, you're going to type in 90 north and then 0 west. So that's going to be a straight line.
And let me interject one more thing here real quick, because this is what happened to me earlier. You have to make sure you use numbers and not letters for 0. Go ahead.
That's it. And then you can see it on the map if you want to. Where's the map? And it's just showing a straight line. Okay. And that's 10,010 kilometers. Okay. So now you have to convert.
Okay. Hold on, Lawrence. You're going really fast here. Okay. Right here, show them on the distance. Use your cursor on your screen to show the distance where you're getting these numbers from, and scroll up and down so you can show them on the screen what they're supposed to be seeing.
All right, so you've put 0 north, 0 west, 90 north, 0 west, and it tells you here what that distance is, and it's 10,010 kilometers. Okay, which you now need to convert to miles.
All right. So let me do that. 10, 0, what's the number?
10010.
Okay. So 10010 is what you just came up with, correct?
Yeah.
And right here is 6,219 miles converted right there.
Okay. So do I need to go back to the other page now?
You're on. You stay right where you're at. Go ahead.
Okay. So what you then need to do is convert your 6,219 miles to scale. So that becomes 6.2. Forget about the 2 on the end of that because you won't be able to read it on your ruler. So take the center point of your map and draw a little marker up 6.2 centimeters on your map.
On your paper, right.
On your paper, and then draw down to the south. So from the middle of the paper down 6.2. So you'll have 2 markers, and then draw in some stronger pencil lines between the 2. So you've got some bold pencil between them.
Okay, so for a second, stop screen sharing and show them your paper or what you're talking about.
Okay.
All right.
So, well, this is the one I've done earlier. Okay, so it's 6.2 centimeters. I don't know.
Get it closer to the camera.
It's 6.2 centimeters that way and 6.2 centimeters that way. So we've done the north-south on the map for the dimensions. So now we need to do the east to west. So we need to go back onto this calculator screen, the screen was on before, to find the distance between 0 and the 180 degrees west and 0 and 180 degrees east. Well, they're both the same. So
go ahead and
one. Okay, so I'm going to
go ahead and go back to that screen share.
Do I need to screen share it again?
Yes.
All right. Okay, just a minute. Okay. All right, so now we're on as it was before, and now we're going to work out the next distance. Okay, so we're going from 0 degrees in the middle to 180 degrees west. So in point 1 on here, you're going to put 0 degrees north, 180 degrees west. Okay, and in the second
point 2.
In point 2, you're going to go from 0 degrees north to 0 degrees west. Okay, and that's going to bring up 20,020 kilometers. So, Laurie, if you can convert that to miles.
All right, the minute the screen goes away, I can't see it anymore. 20 what?
20020 kilometers.
Okay, and that comes up to 12,439 miles.
Okay, so what you need to draw on your map is roughly, exactly, it's just short of 12.5 centimeters to the the latitude 180 to the left. So take your piece of paper and measure just under 12.5 centimeters and put a marker there, and just under 12.5. Oh, my camera's gone out now.
No, you need to go back to stop screen sharing and go back to your camera so you can show the paper.
Okay, so just under, I can't even see whether I can see whether it's on now. Hang on, just a minute.
There you go.
Okay.
You're sharing.
Right.
Go ahead.
So just under 12.5 that way to just under 12.5 that way. Take the marks and then join the lines up. Okay, and when you've got the lines going across, the 4 points that you've got are going to be your west, north, east, and south. Join them all up, and then you'll form the diamond.
Okay, hold the piece of paper up to the camera so that they can see it and not your face.
I don't know whether they can see that or not. Can they see the detail on that there? I can't.
Okay, there you go.
Okay.
All right, so those measurements we gave you, if you join the north and south and the east and west, you will come up with a diamond. And those measurements came from where, Lawrence?
The measurements from there, they came from this calculator for longitude and latitude that we've just been using.
All right. And so for those at home who think that we shouldn't be using government supplied information, okay, all maps, every map, all the time is made from the same latitude and longitude lines. Right. Everything in the world is made from that has to do with travel, distance, mapping, anything and everything is made from these figures of latitude and longitude. They've been around for how many years, Lawrence?
Oh, hundreds of years.
Okay.
I don't know the exact time when they first came out. Okay, but
all right, so now you have your diamond.
Yeah, so what we need to do then now is prove that the diamond shape is true by taking a look at some latitudes in between 0, 90 degrees north and 0, 90 degrees south to see whether it actually fits. So we're going to do two. We're going to do 45 degrees north and 60 degrees south. So we're going to start off with 45 degrees north and work out what the distance is there on the calculator, and then draw it on your map and then measure it, and the two should come out to scale. It should fit perfectly. Obviously you're drawing in pencil and you might not have made your markings in exactly the right place, but near as damn it, it's going to come out virtually spot on. So we're going to start off with 45 degrees north. Okay, so to draw the line at 45 degrees north, you need to be halfway between the dot in the middle and the North Pole. Now the whole distance is 6.2, so measure 3.1 up this line, 3.1, and place a little dot there. Yeah, and then when you've got a dot, yeah, make a parallel line parallel to the equator line across the apex, well, not the very top, this part halfway up the top triangle, but it needs to be 50% between the middle and the top, and draw it across. Okay, all right, so you've got that in place now, and what we're going to do now is go back to the calculator again and work out what the distance should be at 45 degrees north. Well, it'll be the same as the south, but we'll be doing the north on this one. So I need to go back to that other screen and work out the figures on that. So if you just bear with me. All right, share screen again. Okay. Screen share. Share. Okay, we've got that back on again. Yeah. Hopefully, Laurie, back on with it. Yeah.
Yeah.
Okay. So what we're looking at here now is 0 degrees north 0 degrees west. And
I don't think that first one is a 0. I think it's an O.
All right, 0 degrees north, 0 degrees west. And the second one, 0 degrees north, 180 west. So, sorry, we're on 45 degrees, aren't we? Sorry, hang on. 0 degrees north, 45 degrees north, 0 degrees west. Hang on, sorry, I've got a 1 on there. I've actually done that incorrectly. Just bear with me a second. I'm doing it the wrong way. The pressure of doing these things. Sorry, I've got it here. Sorry. 45 degrees north. 45 degrees north. It's just made me nervous that we're getting cut off before. Okay. And then 45 degrees north. 180 degrees west. Okay, so that distance has come out at 10,010 miles again. So you got 45 degrees north, 0 degrees west, 45 degrees north, 180 degrees west. So if you look at the map, yeah, it's giving you the distance of half the distance across the Earth, those bits there. Okay, so that's 10,010. Now that's only doing it's only doing half of it, so we need to get the whole of it. Okay, so the whole of it is going to be twice that, so it's 10,010 times 2, 20, so it becomes 20,020. So if you can work out the conversion on that, Laurie.
Okay, 20,020, which is where I had before, is 12,439 miles.
Okay, so if you take your ruler now and look at the line that you've drawn, yeah, it should come to about 12.4 across the bottom of that line, if you measure it across. But it does on mine. If you've drawn it correctly, it will come out at 12.
All right, you need to stop screen sharing so you can show your paper again.
Okay. Can the people see this now? Because I can't see this now. All right, well, I can't see whether they can see it. Let's have a look. There we go. There we go. So that red line across the top at 45 degrees north, yeah, it should be about 12.4 centimeters. If you've done it correctly, it will be. So that's proving that these things work. You can go and play around with this software yourself and find other latitudes. You know, you just put in the right ones for the right latitudes, and it will give you the distance across, and then you can find where that is on there. So,
okay, let me interrupt again, Lawrence. Okay, stop. Explain how you're putting, what numbers you're putting in position 1 and position point 1 and point 2, and why.
All right.
So if they want to do like 39 latitude or 63 latitude, they know what numbers to put in what slots.
Well, if they wanted to do something like, let's say they wanted to do 63 degrees latitude, they would have to work out 63 90ths. So it would be 63 90ths as a percentage, which is just over 2/3. You'd have to work it out with your calculator. And then you would divide that resulting number into the total distance, which is 6.2. Yeah. So it'd be 63
okay, so
divided by 90, yeah, times 6.2. And then you'd measure that out on there, draw the line across there, and then you go to your latitude calculator for that latitude, and the two are going to match.
All right. Now, I for one, am utterly confused. So I'm sure there's people watching that are confused.
All right.
So well, let's go back to the format that you started with. And,
all right. And, well, what we've got here is 40. The latitude is 45 degrees. Yeah. We want to find out how far it is across at 45 degrees. Okay. So in the box, yeah, we're going to go from the middle. So that's 0. All up that middle line is 0 longitude, all the way down there. Yeah. The line going down is for longitude.
Hold the paper up higher.
Yeah, that's
There
the
you go.
longitude is the lines going down. All
Okay.
right. So we're going from 0, okay, 0 degrees longitude at 45 degrees north, which is there. 0, yeah, to 45, yeah, to 45, which is there. And we need to go all the way over to 180. Well, 180 at 45 is there. Okay. It's showing there at the equator, but because it's coming in, that's still going to be 180. So we need to find the distance from there to there. So we go on the calculator and we put these figures in. 45 degrees north, 0 west, yeah? So that's 45 degrees north there, right in the middle, and 0 degrees west. And then the second one is 45 degrees north, 180 west. The 180 is everything on this edge is 180. Everything along that edge is 180, and everything along that edge is going to be 180 because
Okay.
it's the extremity of the map. It all goes into 0 at the top. You know, starts off at the widest and goes into the narrowest. So when you do that, you're going to work out, according to official information, how far it is the entire distance across the Earth at 45 degrees north. And that's coming out at 12,440 miles, which, funnily enough, is exactly half the distance of the equator, because the equator is 24,880. So you go halfway up the Earth, and the distance across is, that's it, yeah. Halfway up, the distance across is half the equator.
Okay, the words or letters are going to be backwards, but the idea is there's 1, there's 45, and there's 60. There's at the equator, okay? And we're going by these numbers that are showing up on the latitude and longitude, what do you call it? Calculator, okay?
Yeah. Okay.
And so I did it earlier today just to make sure that I could do it because I'm mathematically challenged. And this is my little ruler that I used with centimeters on it. And every single one of the numbers that Lawrence gave me were correct and worked out exactly to what the calculator showed according to my drawing. And I was only off by a couple miles, probably because my pencil was dull. Okay.
That's
so
good.
now do one last one, and you want to do 60
We're going to do
south.
60 south. So according to Robotham, zetetic flat Earth, then everything below the equator on the A map is bigger than the equator, so it has to be bigger than 25,000 miles. But on the diamond, obviously, it's going to be shorter. So we're going to look a bit further down at 60 degrees south to find out how far it is there. We're going to draw it on the map. And once we found out the official distance, we'll measure the distance on the map, convert it to the scale, and it should come out the same. So 60 degrees south, okay, it's actually coming out there. So to find out where to draw your line, well, the whole distance is 6.2. So,
And where did you get that?
That's what we worked out in the first instance when we worked the distance from the center to the North Pole and the center to the South Pole.
Okay.
And it came out at 6.2 centimeters.
Right.
Well, 6.22. Okay. So we've got the 6.2. We know how far it is in centimeters, 6,220 miles from the right in the center to the South Pole. But we need to find out the point that intersects this 0 degrees latitude, 0 degrees longitude. We need to find the point of intersection and how far it would be down. So it's 60 degrees out of the 90. So it's 60 divided by 90 times the actual distance, which was 6.2, and it actually comes out at 4.146. So you can work it out for yourself. 60 divided by 90 times 6.2 is going to give you the measurement of 4.146. Well, you're going to have struggle to draw in 4.146.
So you just round it off to 4.2 centimeters.
It's between 4.1 and 4.2.
Right.
So if you met from the middle, so if you draw down between 4.1 and 4.2, and then draw a parallel line across, parallel to the equator, that's going to give you the line. Okay. So what we need to do now is go back to the calculator at 60 degrees and find out how far across it is there. So I'll go back to that screen. I can find it. Distance. Okay, and now to the Hangout. Screen share. Okay, so that should be, oh, where's it gone? Calculate distance, share. Okay, is that back on, Laurie?
Yes, it is.
All right, so on this one, okay, at 60 degrees north, we're going to start, sorry, south. We're going to start latitude 60 degrees south, 0 degrees west, and 60 degrees south, 180 degrees west. Okay. Okay, now that's coming out at 6,672. Now that's only covering 180 degrees, so we need to double it. So it's 6672 to get the 360 degrees. 6672 times 2, Laurie, and then you need to convert that to miles.
Okay.
Spare me a second.
6672 times 2 equals 13,344. All right, let me do my screen share again. There's a better way to do this, I know, but it is what it is.
6672 times 2, and then on your calculator.
13,344. And that comes to 8,291 miles.
Okay, so
right here.
If you go back, do I need to come off this now?
No. Yes.
Okay. So, okay. Do I need to stop the screen share?
Stop sharing.
Okay. Okay, so it's 8,292 miles. So if you look at the line that you've drawn, yeah, it should be coming out at that amount. You know, just over 8 centimeters, 8.3 centimeters. And that will prove that's the correct distance. Okay. Now, some of you may say, well, hey, yeah, this is still all official information. What other verification have you got? Yeah. So we have got all the verification.
You don't do that. You don't do that mockery thing very good.
Oh, well, no. All right. Okay. All right. So let's actually take a look at a route where a flight that's real and see how far it is on that route, and then compare it to what it is on the latitude calculator. So, well, I'll do the latitude calculator first.
Okay.
All right. And we're doing the infamous Sydney to Santiago route. Okay. So I'm going to put in the coordinates, the latitude and longitude of Sydney and Santiago, and see how far it is on the calculator. So
all right, put that back to the screen share. Go to your
long-winded, but you know, you might have to play it back in slow motion. There we go. Have I got to put this back on again? It's not on yet, right? Okay. Hangout, screen share once again. Share, right? So it's back on again. All right. So Sydney to Santiago. Santiago is.
No, that's not the one. Oh, you are doing the calculator? Okay.
I haven't put it in yet. So Santiago is 33 degrees, space, you always put the space in, 30 degrees, 39 south. Okay,
that's its longitude and latitude.
First one is the latitude, and the second one is the longitude. Okay, so you'll see it on the map because it'll be showing you from Santiago to Sydney, so you'll know I've got it right. If it's not showing that, it means I've keyed the wrong coordinates in. And that is 70 degrees 78 west, so it's 70 space 78
west.
W for west. All right, and then the second point, which is Sydney, is 33 degrees 94 Now,
Space 94.
I've put the space in, yeah. Don't forget
Okay.
the space. All right. And then the second one, the longitude for Sydney is 151 degrees, space 17 east. Okay. If you click on hide map and bring it back on, you'll see on the map. There we go. So you can see the route. Now, look at the route. It's going off the map, Laurie. What's going on here? Why is it going that way? You can't go off the map. It's not allowed. The AE map people don't believe it. It's going off the map. What are we going to do?
I don't know. Okay.
Anyway, so
You got it. Did you do it backwards, Lawrence?
No. That is correct. That's how it should look. So
Okay.
if you look at the distance, it says 11,230 kilometers. So if you can work that out for me.
Okay. Let me go back to my screen share. I'm trying real hard not to be confused, but I'm hanging in best I can. Okay, share. All right. So what number am I putting in here?
11,230 and convert it to miles.
11,230.
Yeah.
6,977 miles.
Okay. And now if you can bring up your other little thing for travel math.
Oh, yeah.
This is the flight routes and see what travel math comes up with.
Okay. We got to go back to that one and get the flight calculator. Okay, now back to screen share. Okay, let's see. We got to go to me. Now, I'm putting in here what?
You're putting in Santiago, Chile to Sydney, Australia.
Santiago.
It'll work. It'll assume that you're going from the airports because it's a flight.
And I'm going to where? Sydney.
Sydney.
Okay, search. Oops, I don't want that. What the heck? Okay, so I want calculate.
Yeah.
Oh, I put it in the wrong one. Okay, bear with me. Santiago. This is how you learn straight up in front of the world. Sydney. Okay, calculate. All right, comes up with 7,063 miles.
Okay, so that's on flight math. And if you go to the travel companies and look at the actual figures quoted by the travel companies, I'll bring one up so you can see it, and then I'll share it. Just bear with me. Come out of this. Itinerary. Here we are. Itinerary to Sydney, Santiago. I've got that there. Let's just bring my screen share up again.
I love how that one really shows the Great Circle route.
Oh, where's it gone? It's not
Australia to.
no.
All right. What are you bringing up?
I'm trying to bring up this route. Hang on, let me bring it up again. I've got it on this screen here. It's showing there. So where the hell's that other one gone? I think you've got to stop sharing yours. Hang on, have I got a one stop? This
No,
one?
you're on. You're fine.
All right. Okay. What again?
Where you going? Travelocity?
No, I was using one of the airline routes, which is. Hang on, I've got to move it over to this side. Just bear with me. Friggin' game.
This show's probably going to be really weird to listen to on podcast.
I've got this photograph here on my main screen, but it's not coming up at the top. It's down as a photograph. So how can I share this? Let's see if I can share that screen. Maybe it'll let me.
Whatever's on this top of your screen sharing is what it will share.
I'll take that one off. All right. So what have I got now?
Okay, so we're verifying Sydney to Santiago to Sydney's miles.
I'm just trying to get it up.
And the distance or the time of the flight, the length of the flight, is that what you're looking for?
Yeah, I'm just trying to bring it up on air because I've got it on this screen, but I can't get it on that one. I think we're the right pair of dummies, don't we?
Okay, well, click on the tab to the website that you want to go to and then share screen.
All right, well, it'll take me a minute to do that then. Let's have a look.
Okay, so
Well, you chat away, Laurie, while I bring this
we
up.
have, believe us, we have done this multiple times, and I know it sounds quite confusing, but the idea is that you have to cross-check from as many different sources as you can so that you're not relying on any one source for the information. And for example, I went on time and date to look for the length of, I went on time and date to look for the length of the sunlight during the day and how long during the day in Antarctica. And one site said that it was all day light, all day long, 24 hours for 6 months out of the year. And when you go to the webcams at the different stations in Antarctica and literally watch the time lapse during the time that they say the light is 24 hours, it's not. So there's one of those instances where you can cross-check the information from different, sites and find out either somebody's lying or somebody's just not updating their websites, or they're putting in wrong information or whatever. So we're going to talk about that a little bit more in a little while, because this is the kind of information that people share and state as fact just by looking at one site. Okay, what'd you come up with, Lawrence?
It's just coming up, Laurie. I've got it on the travel. So I'm using eBookers. I'm just going to get up the flight details.
Oh, so you're actually going to try to book a flight.
I'm going onto the screen where it shows the details of the distance, etc.
So are you going to make that mocking voice about the people who say you're not actually using sites that don't have real flights, are you? All right, well, let's forget that. Let's try something else as a third option.
Well, you can. All right, well, just give me a second. You talk about something else.
So
I had it up. And
let me put another another distance to calculate in here. Okay, what else flights have you checked to see that they are real?
I've checked loads of flights over the past few months, and if you check flight math with the actual flights, with the travel companies, they're usually within, a few miles, 1% of each other, something like that. Right, this is the one I wanted. I wanted this non-stop flight.
Boy, I tell you what, they do show these great circle routes. No wonder the distances are not the same on the land as they are the air distances.
Yeah, just bear with me. I'm nearly getting it now. Right, 14 hours, 10 minutes. But I want it to show the mile, so click on View Details, and I'll share the screen, and then we've got it.
Okay, here's my shared screen. Here's London to Sydney, calculate. There's another, what I was talking about, the great circle route.
I've got it up now, Laurie, so I'm going to
go it
to there.
Go ahead.
Hang on. Got it up there, so I'll go to my what's it and share the screen. Oh, it's locked me out again.
Okay, we're over that.
It says you aren't allowed to join this video call. What's going on?
Well, you're in it. You're on the video call.
Right. Okay, it says you. All right, well,
that's an old one or something. You're in the wrong screen.
Okay. All right, sorry.
I
want to share the screen.
We probably have like 4 people watching now since we had to restart the whole thing.
Yeah.
All right.
I've got to move it over there. Sorry, let's move it over there like I did last time. There we go. got it. I hopefully got it now. I got it.
All
Is it-
right, share screen.
Have we got it?
Oh
Oh,
my
right.
goodness, that's so exciting.
Right. Okay. So as you can see, it's 14 hours and 10 minutes flight journey that way, and it's 12 hours 30 the other. And when we click on view details, which we're on before, you can see it's 7,048 miles from Santiago, Chile to Sydney, Australia. So the difference in percentage terms compared to the longitude and latitude calculator with travel math, one's 98.79%, and compared to the travel company, it's 99%. So you can see that the longitude and latitude figures are pretty accurate. They're not far out, or the other ones are not far out in comparison.
Okay, go back. What was the distance that you just had?
7,048 miles. That's on the screen there. You can see it there, 7048.
Okay, so so I got 7063 according to travel math.
Yeah,
All
so
right.
there's 20 miles difference. So
20 miles difference.
It's neither here nor there in the scheme of things.
Just, I guess it depends on how big the arc is.
I don't know how, they may be using slightly different software to work this stuff out, but you can see that the difference between all three is less than 1%. So it's neither here nor there in the scheme of things. We can be assured, we've been told since we were kids that it's 25,000 miles across the earth, and it is. You can actually do the 3 flights across the equator, and they come to approximately 25,000 miles. It's 2% out or something like that. It's not, I did it on one of the previous shows. Anyway, I've got another one, but I'm not doing it now because I'm getting stressed out with this.
Okay, it's a little stressy. You're right.
I'm feeling like Big Brother's trying to fuck things up for us. The show off, It's really took me out.
Well, I mean, let's face it, we're not like the most techie at all this stuff. That's pretty obvious by now, but at the same time, we're doing the best we can to try to get the information out there and to try to make it real. And it's pretty real. It's like a terrible reality TV show. But the idea is we're not going to win any kind of award with our presentations. That's not what we're after. What we're after is to explain to people that at the end of the day, we're not making this up. I mean, I just saw on Facebook just a little while ago, somebody, said, how do you know the true shape of the Earth? If you use Google for any distance that you have claimed to be lying in the past, how can you use any information they give? And you're making a mockery of flat Earth and, so on and so forth. If this is making a mockery of flat Earth, then all is lost, because from the moment that both Lawrence and I walked in the door of the flat Earth movement, individually, separately, and at totally different times, we were presented with what was called the flat Earth map. And as if, it had been knighted by the Queen herself, or, no argument was given by anyone, because it was Samuel Rowbotham that, created this map, and he's the king of flatness. And unbeknownst to most people at the time, the person that we were thinking was so heroic as Mr. Flat Earth himself was actually a Freemason. I've seen photographs of Admiral Byrd sitting in front of, during his interview, sitting in front of a azimuthal equidistant map, huge, on the wall behind him, talking, interviewing with a guy. And people are, oh, look at that. See, that even more proof. Proof of what? Proof of a psyop that was in the making a long time ago. And if that makes me the ultimate conspiracy theorist, well, then so be it. But these maps, including the UN map, which is also a version of the azimuthal equidistant, just flipped around a little bit to make Europe as the center point instead of the USA as the center point. The whole idea is that these maps are projections, and they are the most aesthetically pleasing projections of smashing out the globe. The problem is that it skews every one of the southern hemiplanes, continents, into not only being squatty and shorter, but being in the wrong place than what they really are for distances. Those who have come before us have tried, like, let's just say Tiger Dan, for example, who tried to make a map, tried to take the measurements of distances from airline flights and plot them out on the AE map and show that the AE map was wrong or right. He did that at the urging of people like Lawrence, who said it wasn't correct. And interestingly enough, Tiger Dan had a meltdown because he couldn't figure it out. I mean, he just literally couldn't make it work. So instead of having a meltdown, the thing to do is to start over and say, okay, then what does work? And as we were going through the progression, one of the things Lawrence did, this is how we stumbled upon the diamond map. One of the things Lawrence did was he went back over someone who's supposedly a very strong advocate of the flat earth and well known as somebody who made all the clues, and that's Mark Sargent, the map maker's clue. And Lawrence went back and watched it. It's been a long time since he watched it, and he stumbled upon some clues that were probably unintended or maybe left in plain sight. Who knows? But as time went by, Lawrence got it in his head that it should look like this or it should look like that because this is what the numbers are saying. And when he saw the sinusoidal map, it clicked. That looks more realistic. And then he saw the diamond-shaped map, which is called the Collignon map, that was done in 1865, which is another projection, which is the diamond shape that we're working with right now. And it works. The numbers work. So it's pretty hard to ignore that they work. And the only reason why you would ignore it is because you either have cognitive dissonance for the second time. When you stumbled upon flat Earth, you probably had some pretty serious cognitive dissonance about, well, what are you talking about? The Earth is flat. And what do you mean the sun goes in a circle? And here's this little map. And isn't it cute? And doesn't it look simple? Well, as far as Lawrence and I are concerned, and a growing number of others, not only does it not work, but the elements that make it up to create it into a model for flat Earth don't work. Like the sun doesn't go in a circle. It goes in a straight line from east to west. So bear with me on one more opportunity to do one of our wonderful screen shares. And that is, I'm going to go to timeanddate.com.
Let me just say something before you do that, Laura.
Okay.
The map I showed you last week, which you've got all the routes on, which were coming out very accurate. There was nothing particularly far out. I've actually I took about 15 or 20 longitude and latitude readings from places on the coast of Australia and joined all the dots, and it's coming out a mirror image of the Collignon map. That map. So if I do any other, I might do Africa, but I'm not going to do the whole thing. It would just take far too long. It's the Australia on mine is exactly the same as the Collignon. So I'm going off the Collignon as being the correct map. I was going to draw the whole bloody thing, but you know, it would take me months to do it because particularly places like Canada and all those inlets and bays and things like that. It would,
Well, there's no sense in having to remap the world if someone's already done it.
Yeah.
And if the numbers work, and you
That's
know,
right.
the math works, then it works.
It does. So
So
Calignan, as far as I'm concerned, it meets all the criteria, flight distances, you know, some slight adjustments where there's a big Great Circle route, you know, it could be a little slightly out, but the ones that go in east and west on a straight line and north and south, they're coming out pretty much spot on. So the map is good.
okay, let
So
me
back
bring
to
up one
rainbow.
other. Let me bring up one other issue that someone brought up to me today or yesterday. That said, they showed me a link to an article that was about in the future, the airlines are going to have gotten permission to fly over the Arctic Circle, to fly over the North Pole, to cut distance off of plane routes. And it's going to take hours off of flights coming from, say, Russia to Alaska or Canada. And so they said, how does that work on your diamond-shaped map? I mean, there really isn't even hardly any North Pole because it's all squeezed down to a point. And the same way with Antarctica, squeezed down to a point. And yet the size of the continent of Antarctica on this map is roughly about what it looks like from the, you know, globe map. And one of the things that I find curious is why people have such a hard time and want to remake everything, because that makes it just that much harder to understand reality and to, I guess, sell it to newcomers. I mean, from the time I heard about a 2-mile high ice wall all the way around the world, around this AE circular map, I was like, we'd see that. Somebody would see that. I mean, 2-mile high ice wall is pretty high ice wall all the way around. And then he's like, well, no, it's not actually 2 miles high all the way around, just in some of the parts. Well, what parts? What parts is it and what parts isn't it? Well, we won't know until we go to Antarctica, and we can't go there because we're prevented from going there. Well, then you have people who say, no, I've been to Alaska, or I've been to Antarctica. Lots of people go there every year. And that was one of those other mythological things that you're sold into the story of flat Earth at the beginning. You know, that's why we can't go there, because you'll get blown right out of the water. Well, other than the story that I heard about Jarl Andhoy, I haven't heard of anybody else being blown out of the water. And, you know, I guess there's a possibility that if they blew everybody out of the water and there were no survivors, there was no one left to tell the story. So I guess that's a possibility. But why stretch the story? Why make so much mythology if we don't have to? And if it isn't true, if it can't be verified. And as of right now, there's been quite a few people who have gone to Antarctica and sailed around. Now, one thing we know that no one has been able to prove is that no one has circumnavigated the Earth pole to pole and back again. And that was another story that someone, you know, brought up to you and I both about Ranulph. How do you say his name? Ranulph Fiennes.
Yeah.
From UK, who supposedly over, God, it was like 19 months or something, or almost 3 years, to circumnavigate from pole to pole and back again. But I can find no evidence other than, you know, the fact that the Queen knighted him for it, and he's in the Guinness Book of World Records as the only person, or the first person, or actually, I think he's the only person who has ever circumnavigated the Earth, polar circumnavigated. And just because he's in the Guinness Book of World Records, do we know that that's true? you know, this is one of those things where damned if you do and damned if you don't. If you believe this, you can't believe that. If you believe that, you can't believe this. So then which one do I believe? Which one's true? So the idea of, well, they've given permission to airlines to fly over the North Pole. And so they're going to start doing that. But of course, they haven't started yet, just like they haven't started building a bridge across the Bering Strait, the 55 miles that links the North Alaska with Russia, with this little island in the middle that we talked about a little more at length last week. They've been talking about building a bridge across there for a long time. I mean, years and years and years, and since before the Cold War. And it's never happened. And it's 55 miles. It's not like it's the most cost prohibitive thing in the world to build a bridge across there. Even if it was just a little 2-lane bridge for a few people who wanted to drive across. And so I speculate they can't do it, just like they can't fly over the North Pole. But that doesn't stop them from talking about saying they're going to, just like we're going to go to the moon. You know, they talked about we're going to go do this, that, and the other thing, Kennedy said. And as most of us believe that, of course, he never went to the moon because you can't on a flat Earth. So the whole idea of doing this workshop, I mean, I'm sure you're going to laugh, and it wasn't much of a workshop as far as workshops go, but at least we showed you the methodology. If you have the energy and the inclination to go to these websites, they're listed in the description box below the video, and try it for yourself. Draw the map. Run the numbers. It just takes a ruler, a pencil, and a piece of paper with a ruler with centimeters, and the understanding of how to go about it, which Lawrence explained. And perhaps we need to write down the formula so that you can go do it step by step. But I want to talk about the time and date and the sun going in a straight line, because it absolutely imperatively goes along with this concept. And there's no reason to ignore that. The only way this works is that there's some kind of a seamless wormhole or something from east to west at the 180 degree point. Whether you want to say it's at the international date line, which is a jiggity jaggedy line, which really is just some arbitrary line that gets moved around based on who's in political power and who wants to be on what time or what day. But before longitudes were ever marked out, latitudes were around a long time before longitudes were just created. And it is a man-made creation. So there's 180 degrees across this map. And at the 180 degree mark, that's where something happens to bring you back to the other side. And I'm going to go to this time and date, and we're going to go over it a little bit more in detail so that people understand what's happening here. Is that presenting? Yes. Okay. So here's the timeanddate.com, and this is the day and night world map light, the way the light works on Earth. And people say, well, you know, how can it even work like that? It's like right now where I live is where it's coming up, and it's a big square. And then it, you know, has a fainter and fainter and fainter darkness to lightness. And when you look at the bottom, it says, has this down here, jump to -4 weeks, minus a day, minus 12 hours, 6 hours. So I'm going to plus, an hour and bring it up again. And as you can see on this map, this is another one of those, this is reality, this is hide in plain sight, even though people ignore it and say this is not true. Here is the sun. I can advance it another 10 minutes. And now it's half off the map. And right there is that 180-degree international dateline end of this map location right here.
That's it. And you've got the,
and look at that over on the other side. Here's the other half of the sun coming in on the other side. Not only that, but here's half the daylight and here's the other half of the daylight, and it's dark in the middle. And I invite anyone to go on this timeanddate.com, and you click up here on where it says sun and moon, and you do the sun calculator or the moon calculator, and or you can do the day and night map, which is what I've got up right now, and you can advance it or move it. You can go 4 weeks ahead, you can four weeks behind, and it'll tell you what the light will be at that particular time. You can go to the March equinox, the June solstice, the September equinox, or the December solstice, and you can see what the light will be like at that given time. And over here's the moon, and right here's the sun. And as you can see, it's in its southernmost location as it goes across the Earth. But if I keep advancing, let's go back to now. Okay. If I keep, if I do the March, okay, let's see where we are. We're closest to that. So I'm going to go do March equinox, and I'm going to show you that the sun is more southerly. Okay. And then I'm going to do June solstice, and now it's more northerly. Okay. And then I'm going to do September equinox, and now it's in the middle again at the equator. And then it's December solstice, and now it's down in the south again. So it literally shows you that the sun tracks northerly and southerly as the year progresses. So what about this can they fake, for example? Because anybody, anywhere can go on here and verify where they live. Here I am right here in Florida, USA, and that's exactly what the light looks outside. And it's starting to get a little bit dark. And, if I move it ahead an hour, or no, that's back an hour for me. Then let's go back the other way, 6 hours. Okay. Look at the different way that the light shows on this map. Okay. So I know that this is not the diamond map, because it's obviously a Mercator, and it has Antarctica all the way across the bottom. It never shows anything to do with the Arctic ever, anywhere on any of these maps. You can't even fly over it on Google Maps or Google Earth. You can zoom out as far as you want to, but you can't really ever look straight down. We never see any photographs of the Earth from so-called space or high orbit or anywhere directly over the Arctic or the Antarctic that aren't some kind of simulation. So the sun travels in a straight line.
Everything does. The sun, the stars, the moon, they're all traveling in a straight line, Laurie. That Freeanergy, he brought out a fabulous video in the last week showing you how the stars really work. In fact, they'd work even better on the diamond map. So if we can show it shortly. And the interesting thing about that video is that Jeranism, if you're watching, Jeranism was very impressed with it and invited Freeanergy onto his show. That's the first person in terms of the well-known flat earthers to actually mention the name Free Energy. Nobody's mentioned it apart from us, and now he's getting a bit more attention. I don't know whether he's going on the show or not, but people are starting to talk about him now because what the stuff he's putting out. For me, Free Energy is he's the Nikolai Tesla of flat Earth. He's the best brain in flat Earth, and he's been largely ignored by the masses. You know, his video should have received hundreds of thousands of views, and you know, some of them have only had 5,000-10,000 if he's lucky.
Well, here's the video you're talking about. It's called Stars in the Firmament Explained. The Earth is a Flat Square.
Well, say it running then, Laurie, and we can stop it where we can show them that the diamond-shaped map would actually work better for the stars that in the arrangement that you're saying that they are. Well,
for those who've not found his channel, it's Freeanergy, Anergy, Freeanergy. And I mean, look, he's got 1,800 subscribers finally. He should have 18,000, but no one has really found him yet. So here's you're not going to hear the sound because it's just some music playing in the background, but let me go to full screen on this and see if that. So all the stars are circling
appearing to, yeah,
around Polaris, or appearing to. The size of each circuit depends on how big or flat the light wave is. Some of these videos, you have to watch them. You know, here's eastern portals and western portals. And this map is upside down compared to what we're used to looking at.
That's why the east is on the west.
Right.
Because he's got the map upside down there. But
big waves and flat waves.
Looking at it, doesn't it? Yeah.
Yeah.
But the interesting bit is when he comes on to the distribution of the stars, and the biggest distribution is over the equator, which is the widest point, and the smallest distribution is towards the poles, which is the shortest point, which fits perfect with the diamond. You'll see that shortly when he brings that bit up on the video. So just bear with it for a while. And,
what we also observe is a difference in the amount of stars within each circuit. This is another interesting idea that most people haven't really paid that much attention to. Each circuit covers a certain latitude over its entire length. And he's showing the northern latitudes. This means that the amount of stars within the small circle is the amount of stars along the latitude north 84. The amount of stars within the big circle is the amount of stars along latitude north 75.
And of course, you'll get people like what's the guy who's calls himself Zetetic Flat Earth? Jeffrey Grupp. He will tell you that there's a dome over the top of us that spins round to create this effect.
Well, lots of people believe that the stars are spinning around in a dome. There it is.
Freeze it on that one, Laurie. Okay. So this is by latitude. So if you look in the middle, yeah, that's the equator. That's got the most stars, and then as you move further south and further north, you get fewer and fewer stars. Now, if that had been put in a diamond formation, the stars would be equally distributed, but they would be less. But in terms of the amount of stars per distance, it's going to come out pretty much the same. But that reflects the fact that the latitudes get smaller and narrower across as you get further north and south.
So again, he's got it so-called upside down. This is the northern foundation, southern foundation.
Yeah.
The equator contains the most stars within one cycle. And that was obvious by the spinning figure that he showed earlier. Further north or south, the less stars.
That's because there's less distance across.
Right.
There's going to be less stars able to, fit in that space.
So you can see right here, there's very few stars and less, and then it gets more and more until the saturation gets more and more. Of course, these are leaving trails. This leads to the conclusion that the visual stars in the firmament are distributed in a specific manner. I think this guy is really a great thinker. And so what could provide such a distribution? Now, this is where he gets his idea that the stars are projected up onto the upper solidity. The star becomes visible stars we see are projections on this Book of Enoch. Orb of heaven. People say they don't want to believe this pyramid or diamond shape because it's not biblical, but there are as many cross references biblically for this projection as there is for any other. Four corners of the earth. Now, if we could get him to make our animations for us, Lawrence.
Yeah, it's pretty cool, isn't it?
Oh, boy. The geographical Earth is exactly 40,000 kilometers long and 20,000 kilometers wide, which is exactly what we came up with with the diamond.
He's showing the Mercator in its usable form, but when you put the scenery in at the top and the bottom, you get the diamond. There we are. He's saying here, an area twice as long from east to west as from north to south.
Right.
Yeah.
So there you go. I mean, I say there you go. He's slowly but surely coming into. There's the pyramid tent of heaven.
Yeah. They are the Triffids.
There's the equator, eastern end, western end. That's where they come together. I think in a second here, he shows the part of the star trails where it's divided north and south at the equator. And to me, that's a slam dunk. I mean, doesn't this make the simple little flat round AE map with a dome plopped over the top of it seem pretty simplistic at this point? I mean, I'm not saying this is the way it is, but this is a little more mind stretching than the AE map, because it doesn't answer to all of these issues.
Yeah, well, they'd have us believe that it's just like as Mark Sargent says, it's one of those child's things that they have that twists round, above him. But
what, a top?
I forget what the name is. Those kids, little children. They have these. I don't know what they're called.
What this is showing why there would be a decrease in stars at the north and the south, but it also comes out the same way on the pyramid, or I mean on the diamond. I keep saying pyramid. So East, west, north, south. This also explains to me why you can't see the stars when you're only in a so high altitude in a weather balloon or whatever. Nobody can ever see the stars because they wouldn't be projecting there. They have to project all the way to the ground or pretty close to in order to be able to actually see them. If that makes sense. Makes sense to me. One of those, it makes sense in my head things.
You need to watch this a few times to get your head around
Yeah,
it. This
for
guy
sure.
he's way ahead of us in terms of his thought process. He just needs to modify it a bit to change the shape to reflect that Mercator's map is actually stretched out towards the top and towards the bottom.
Way over here is where the straight line is going to start to come together. This is the part that is a little rough to wrap your head around when, by the way that he's showing it, until you watch it several times. Now he has a north and a south light, which is another issue that people have had problems with the AE map.
So you've got the stars there.
Southern and northern and southern pole star likely is the same star.
When you see it on here, the stars are all moving in a straight line from one side to the other, aren't they? They're not moving around in a circle.
Right.
They just appear to move in a circle because of the bending of light. See, that's like looking down on the stars from above them, isn't it? So we're looking up them the other way, and they appear to bend and form these.
Well, he's showing the bend right there.
Yeah.
It's pretty fascinating. So that would be a mirror ball, a star mirror ball.
Well, that's cool. Now, you mentioned something earlier today, Laurie, about you was having a look at time and date for the Antarctic, and that's actually telling you, and it seems that time and date, because we do check things out, and if they are making mistakes, we do point them out. It's saying right now that there's 24 hours of daylight in Antarctica, but if you go to Casey Station, which we can bring up in a minute, you can actually see the lights coming on in the building, and people say that this is just all made up fictional stuff. You can see all these people coming and going and vehicles coming and going throughout the day. It's, you know, as if they'd had actors pretending to be at the Antarctic
in freezing
all year
cold.
round, 24/7 for the past 15 years. It's ridiculous. I'll try and bring that one up because I don't think you've got it, have you? I'll bring up Casey.
No, I don't have that one. I have the date and time. The reason why I you know, I need to verify all the problems that are wrong with the AE map and not just some of them. And the one that seemed to be the most contentious was whether or not there's ever 24 hours of sunlight in Antarctica. We know that there is in the North Pole, but people argue that there isn't in the South Pole because it wouldn't work on the AE map. Because the sun never tracks south enough and couldn't track around fast enough. I mean, people have actually said, well, maybe the sun moves faster in the southern hemiplane on the AE than it does in the north. Well, again, why do you need to stretch and make up ad hoc theories to make something work when it's falling apart as it is? You know, it's like putting Band-Aids and duct tape and splints all over it. And why would you need to do that? Just come to grips with it's not perfect. And if it's not perfect, then what is wrong with it? And if there is enough things wrong with it, then, you know, you need to look elsewhere for what the real map would be. So I looked, and timeanddate.com, literally, this is one of those times where you say, okay, this is unverifiable information. And not only that, but it's incorrect because timeanddate.com has I'm trying to think of where I wrote it now. I shuffled all my papers around to make room for my map.
So I show them.
They have September 21 to March 22 that the sun is up all day in Antarctica. And that's roughly 6 months. And they say that in the north, which the furthest north you have a weather station that's keeping track, is in Nunavut, called Alert. And they say that between April 7th and October 15th, that the sun is up all day in the north. And that's the opposite 6 months, roughly, almost, to what the south is. Well, we know that the sun only goes as north as the Tropic of Cancer and only goes as south as the Tropic of Capricorn, which is roughly the same distance apart from the equator. So if the AE map were true, then the sun should not even ever hardly get to Antarctica, and it would be 24 hours a day sun longer in the Arctic. But we need another source of verification because timeanddate.com is wrong, because we compared it to the webcam. Show the webcam.
Okay, let's go for that.
Now there's people who say, oh, you know, Lawrence is all balled up about the webcams. Well, I looked at the webcams too. And
we got that on now, Larry? Is it up and running?
Yeah, your screen sharing. Let's see. Okay.
Yeah, so this is the webcam. So you can see this is, you've got the date, the time at the top. I'll play it twice so you can see. Now you can see all these people coming and going, and cars coming and people going in and out of buildings. And it's different people every day. It's not, they're not always walking in the same direction, and it's not the same vehicles. And you can see by looking at the timestamp, it gets dark about 12 o'clock at night and gets light at about 8 o'clock in the morning. So you've got about 16 hours of daylight now, and that will gradually go the other way. So you've got 12 hours of daylight and 12 hours of darkness. And that's the reverse of what you're going to have in the north at the moment, because up in the north at the moment you've got about 8 hours of daylight and 16 hours of darkness. So one is always the reverse of the other, except when it's, you know, 12 hours of daylight and 12 hours of darkness, you know, in the in-between stage. So let's just give that another run. So at 1:15 a.m., which is when it starts, it's dark, and it gets light at 7:30, just after 8 o'clock. So you got light from 8 o'clock, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 o'clock, just about 12 o'clock, it goes dark again, and the lights come on in the buildings, and the street lamps they've got outside come on. So I'll stop sharing that now.
Okay. Okay, so that does not match up with what Time and Date has, because they have 6 months basically, and then from one day to the next, suddenly it goes from the sun's up all day to like normal. And that's not how it works. It doesn't work. The sun's up all day, and then tomorrow we go to the sun up part of the day. It obviously phases out in the north and the south, just like it does everywhere else. And so that information is not correct. And I'll be the first to say that we know that there's at least close to 24 hours a day of sun, and we need to go and find the right day or time or month when that is supposed to be happening and run the webcams then. And we need to go to several different locations in Antarctica. According to the ice ring theory, those stations would be all the way around the perimeter of the Great Flat Earth Circle. And what longitude and latitude would they be at if they were all around the outside? That's the part that's very confusing, is that whole longitude problem of it being in a ring or in a circle, flattened out circle. The longitudes don't quite work out so well because they get wider as they go out to the perimeter, of course. The latitudes get a little farther apart, and the longitudes get way further apart and come to 0 at the center, which is right on the diamond, but not on the AE.
Indeed.
So what else you got, Lawrence?
Well, we covered.
I don't feel like we're going to spend a whole lot more time addressing the map anymore.
No, I think, we may start trying to have a look at some other stuff that's other misinformation. The stars is the hard one to get your head around, and it's hard to present because, it's not something you can get a good handle on because we're down on the ground. But Freeanergy is a brilliant brain, and you need to watch all his stuff because it makes sense. And he's on a different level to us. He's the man.
Well, hopefully he's watching or does watch this presentation. I'm going to share it with him in a so at least he can have a good laugh. If for no other reason, I'm going to share it with him in a message, and maybe at some point he will address the shape and see how it works within all the other model information that he has.
Yeah. Well, the people at home can actually go and check on that calculator that we've put on the link. They can go and check, places south of the equator, and they can see that the distance across the Earth, the further south you get, the narrower it gets. That completely debunks the AE map. It doesn't stand up. The AE map has to be consigned, but if you look on YouTubes that are coming out, people are still shoving this stuff out, and they're even sticking it on your Facebook page and asking questions about it. So, but what's his name? Daniel Pratt. Is it Daniel Pratt?
Yeah.
Yeah, I was listening to one of his presentations today, and I heard the word diamond-shaped map. So,
oh, really?
And somebody on Patricia Steer's show mentioned the diamond-shaped map. So,
has she had her Mapageddon thing yet?
No, not yet.
No?
I don't know whether she will now, but because whoever does it has to address longitude and latitude, and if you do that, you're only going to get a diamond because if you want to start arguing that longitude and latitude are incorrect, then all GPS works off it, all the tracking systems work off it. It's a square system. That's what they use, but they can't use it on the diamond-shaped map because they wouldn't be perfect squares. But that is the true state.
Okay, so but they do use that funky. Let me see if I can find that funky sinusoidal type map. Where is that? Oh, here. No, that's not it. Yeah, here it is. Let me screen share that. They use this map, and this isn't that far off, Lawrence.
Yeah, it's close. Yeah, it's close.
I mean, but it's got the point here and the point here. It's just, and it's close to twice as wide as it is high.
Yeah,
but I'm sorry.
If you go up to the higher latitudes, it's too far across, which is what I found. When I did the presentation on this map, in all the places where most people live, then the measurements are pretty accurate. But as you get further north, it's too wide. So it needs to be squashed in a little bit and squashed in a bit at the bottom, and that gives us the Calignan map, and that's looking pretty much spot on.
Well, this map is the map that NASA, NOAA, and all those organizations use. You can see all these little squares they've plotted out on it, and they're all numbered rows, bins per row, so on. And this is where they fly over and take photographs of things like weather and topography, and then they plot it on these into one of these squares that correlates with what it is. So it's not an impossible map to use for that purpose, because they're using it.
Why wouldn't they be using the AA map then, Laurie? That isn't that the
I don't know if it's the official map of the USGS. They should be using it.
Mark Sargent said it was, wasn't he? He wouldn't tell you lies, would he?
No, he wouldn't. So the whole idea of the mapping is, we found flaws. We tried to address it. It made us outsiders. It made us on the fringe, and I'm completely happy being on the fringe if I know the truth. I really don't care to be mainstream if mainstream isn't the truth. And this is as close to the truth of verifying. I mean, and how can you, someone would say, well, you're using airline information as a cross-reference. Well, people actually take these flights, and they actually do make connecting flights. So the times and the dates and the distances have to be pretty practical, or you wouldn't be able to fly people all over the map every day, day after day, and connect things up if the numbers were wrong. So, and if the times were wrong. I mean, people have sometimes 10 or 15 minutes or a half an hour to make connecting flights. And, you can say these flights don't exist, but it would be easier to say, the things that people say exist, then you have to find a way to make it fit the reality. And that's why this map works. Now, whether or not anybody likes it or not, there has to be some kind of an unexplained portal, wormhole, seamless transition. I don't know what you want to call it. Everybody laughed, haha, it's a Pac-Man map. And, I thought that was kind of funny for a little while, but the only thing is comparable to Pac-Man is a video game where the little man goes off one side of the screen and instantaneously comes in on the other side, but it's a video game. And so that's not exactly how reality works, but it is, I almost sounded like Mark Sargent there for a second, but it is a model that came from somewhere, whether it's just came out of somebody's head in a video game, or that's how the programming was made, or whatever. But the idea for that Pac-Man game, the concept is kind of the same. So I'm not going to act like it doesn't exist, and I'm not going to act like, I'm embarrassed to be made fun of because Pac-Man. So, but there must be another explanation, because Freeanergy is on the same path, and he has listed east and west portals, and he's using Enoch as his cross-reference, I guess, if you want to call it. And before the Bible was written, the book of Enoch was considered pre-biblical text. And so he has an explanation in there for how these gates and portals work. And that came from somewhere. I mean, a guy thousands of years ago would be pretty space age, pretty Jetson to come up with that on his own, don't you think? That there's portals.
I've drawn in Australia on the map, so I just thought I'd like to show the viewers what it actually looks like, just to show it, So I took about 15 to 20 reference points and got the longitude and latitude. These are places on the coast of Australia. Anybody in Australia looking in, you can see what Australia really looks like. And what I've got on here is pretty much the same as the Calignan map. I could have got it more detailed, but it would have took more time. And I was getting that many pencil lines doing all the intersections. I just decided to restrict it to about 15 to 20 points of longitude and latitude for different cities. So I'm going to turn your webcam over here.
Oh boy, here we go again.
And you can take a look. There we go. At what Australia looks like. So let's have a look. There we go.
Oh, I'm
That's
so
Australia.
sorry. That's
You got
funny.
Australia now? You've got it, yeah? That's
Okay,
Australia.
we got it.
Yeah. Which does mirror the Calignan. If you go and take a look at the Calignan map at Australia, you'll see it's pretty much the same as that. That's a little bit more accurate than mine, but
Well, I have the Calignan map. Let me pull that up, and let's see, where is it? There we are. Okay, so there's Australia.
Yeah, and you can see the map I gave you was pretty much in the same sort of shape and slanted in the same sort of direction.
Yeah, because
I'm working to the same methodology that he's got with that, but obviously doing mine by hand.
well, here's another thing that I think is also realistic about this map, or much more realistic than the Mercator or any of the other projections, and that's the size of Greenland. The size of Greenland goes back to where it's supposed to be. Africa is like supposed to be 14 times bigger. It actually isn't in area. It's more like maybe 11 or 12 times bigger, but this is much more realistic size.
Well, that's the real map.
Right. Well,
It's the Mercator map concertinaed in to reflect the actual correct sizes of the continent.
Here's another interesting fact that a lot of people never paid that much attention to, but 90% of the population lives above the equator. And when you look at the amount of the continents that are above the equator, it's much more obvious to showing here on this map than it is on a globe map even. But and you know, even on the AE map, you have India, Asia, Japan. You know, most of the people live in that part of the eastern longitude also. But the idea that you have concentration of the continents in the north, it's, I don't know, it's just every little aspect of things that I think about that were problems to me with the AE map, they're so much more solved here that what about this New Zealand? Is it that long and skinny as much? I need to probably look at a Mercator map to see, but it is a long skinny island, right?
Yeah. I'm sure there's a more detailed one that you can actually get. That, you know, this is obviously. Yeah,
this is 1865. I think he did pretty good for 1865, don't you think?
Yeah. But,
so, okay, so I think I want to probably wrap it up at 8 o'clock our time.
Good thinking, Laura. Yeah.
And
you can have an early night.
We both got a little stressed with the kickoff of this show tonight, with getting locked out and
that was
having to start a whole new link and every other kind of thing. My adrenaline is crashing right about now.
I'm amazed you got back in, because you had to do a brand new hangout to get it started. Everywhere I turn, no, you can't come in, you're banned. You are not allowed to join in this hangout.
It was just, I don't know. the whole idea that we wanted to try to do with this workshop, I think we sort of accomplished. Maybe not 100%, and maybe not to most people's liking. I get comments all the time about how crappy our presentations are, and how you know, we have so many technical difficulties and every other kind of thing. Neither Lawrence or I are, you know, tech savvy, and if it weren't for Google Hangouts, we probably wouldn't even be able to be doing this, because it's just an easy format for us to talk, and we spend very little time actually conversing between shows in the week because we're both busy people. Lawrence has his business with his essential oils, and I have my art and decorating and designing business and consultation. So I'm pretty busy myself. So we do the best we can with the time that we have. But I hope that other people who do better presentations, do better videos, the so-called flat Earth YouTube crowd, I hope more of them pick up on this and start to do their own verifications. I mean, that's all we're really asking for, is for them to verify it themselves.
No copyright.
Test it.
Take this information and run with it. We just want the truth. You know, you can probably present it far better than we can. I mean, it was a bit of a dog's breakfast today, but I got pretty spooked when I couldn't get back in, and I was locked out for, you know, in all the shows I've ever done, we've done about, I don't know, 16 or 17 shows. I've never been locked out like that before. I think somebody threw a spanner in the works. Yeah.
Well, like you said earlier, when we did our promo, the promo wasn't bad. We did that pretty good, because that was only 4 or 5 minutes.
I thought it was quite funny, actually.
If you haven't seen it, go on the channel, Flat Earth Conspiracy channel, and look for Free Our Flat Earth episode 4 promo, and get a good laugh, because Lawrence took his AE model that he used for a long time, and it was, what did you have that built on anyway, Lawrence? Was it like a pie tin or something?
It was built on a silver type tray, and it was made out of plaster of Paris, and then I cut out all the shapes of the continents and made them out of plaster of Paris, and then got it all painted. And I used that at presentations, but took the axe to it, or some implement I found in the tool cupboard, and smashed it up, but made a bit of a mess.
Yeah, you did. I got a kick out of that, and it ended up in the trash bin, because it's done. It doesn't, you couldn't use it again for a presentation, and now you have your pizza tin back, or whatever that was. And you know, we're not out to be arrogant. We're not out to make fun of anyone. We're not out to act like we're smarter than anybody else, because it should be evident that we're not, based on you know, our methodology to our presentation. But struggle through it we did, and we have. And
yeah, and if you've got any questions, stick it on the comments on the video. I know it wasn't the best video ever, but put whatever comments you've got, and try and debunk what we're saying. Try and debunk the fact that latitude across the Earth gets narrower as you move further north and south away from the equator. You can't debunk that. So if that is true, the shape has to be a diamond. So debunk it if you can. But I don't think you can. And if you can't, and you agree, then say you agree and start getting this real map out, because you know, in all honesty, it's the only map that fits reality.
Well, and here's the other thing. Even like I said, even though it's not the greatest video, when we struggle through it, share it with other flat Earth enthusiasts that you know, and let it explain to those who. Here's the thing. There's a whole lot of people who say, well, I know the AE map has its flaws, or I know the AE map isn't perfect, or yeah, we know the AE map, you know, it's not. The AE map was implanted into the flat earth movement from before we ever got here. It came from Robotham et al., from the Flat Earth Society, who we all know at this point are all false disinformation and misinformation and counterintelligence bullshit. And everybody makes fun of, oh, you don't really believe the Flat Earth Society. I mean, after all, they say to make up for gravity, the Earth moves up at like 9 inches a second or something to keep everything on the ground. I mean, how ridiculous is that? But yet, that's where the AE map, that's the bunch that the AE map originally came from. And if you go back and look at the beginning of where the Cetetic Society, what are you clicking on, Lawrence? If you go back and look at the Cetetic Society, that they were a bunch of Freemasons. And so on one hand, everybody's like, oh, the Freemasons and the Jesuits and the Freemasons and the Jesuits, but nobody seems to have a problem with, these are the guys. Admiral Byrd started the very first Masonic lodge. One of the first things he did when he got to Antarctica was create a Masonic lodge. I mean, really? There's like 10 people there, and we have to make a Masonic lodge out of it. You know, and he's the one who said that Antarctica is the size, this huge, huge size. Well, we don't know how huge it is because we don't know how far it goes to this point. This point could be, he came up with a hollow earth. Well, maybe that's what the southern point and the northern point of the AE map, or the diamond map, the Collignon map, maybe that's where it goes, back toward itself, inside of itself. Maybe there's another portal there, or 2 portals. We don't know, but there's something going on there, and those are the 2 areas we can't get to. So whether or not they're seamless or not, like the east and west, because nobody seems to have a problem with us traveling from east to west all the way back and forth and around and around. You know, last week I talked about possibly it's a Mobius strip. Who knows? Perhaps it's, you know, a linear thing where it's like a roll of wallpaper. It goes 8 rows that, or 8 pattern repeats that way and 8 pattern repeats that way. Nobody can travel that fast other than Superman to come to the end. Obviously, if there is an ISS, or there isn't an ISS floating around up there, but whatever is playing like it is, that people think they're seeing, it is making a circuit like this across the Earth plane. And so it has to be seamless up there, just as seamless as it is down here. So nobody can argue that we haven't tried to explain, but there comes a point where this is probably beyond human comprehension, without help, without secrety information that only a small number of people are privy to. So that's one of the reasons. Another one in the many thousands of reasons why we need to overthrow those who are holding all the secrets. So,
Laurie, and I've got some research for people, Laurie, that, you know, if you're watching, this is some research that you can do. We've got the spring equinox coming up, and for those that you look at time and date, the spring equinox and the autumn equinox, you have 12 hours of daylight and 12 hours of darkness. They're in balance. So if you go down to the beach, you should see the spring equinox, you should see the sun, if it was circling, do a 180 or east to west. But so you could go there and actually take some measurements of where the sun is when it rises and when it sets. Buy yourself a compass. You can get one for about $10, or, you know, 10 quid in the UK, or that, you know, depends how much you want to spend on a compass, but they're not expensive. So you can actually go down to the beach and mark out where north, south, east and west is. Have your camera, you've got a point of reference, see where the sun rises, see where it sets. And then on the longest day, June the 20th, June the 21st, it's one of those 2 days. The sun in the UK, so if you're above 50 degrees north or below 50 south, the sun is out, well, sunrise and sunset are 16 hours apart. Now, 16 hours out of a 24-hour day is 2/3 of the day. 16 over 24, 2 eighths of 16, 3 eighths of 24, 2/3. So 2/3 of 360 degrees is 240 degrees. So if the sun was circling, you would see it rise in one point and set 240 degrees further round on the longest day, but you won't. And you can prove it to yourself. Get out there and do it. We know there's a couple of thousand you at least do watch this, or the numbers went down last week. Maybe we were getting a bit boring. But you can do these experiments yourself. So do the spring equinox. Go and see just how far the sun appears to arc, and then go on the longest day, 3 months down the road, and see what it's doing then. And if it's doing exactly the same, then you know the sun isn't circling. So
That's
there's an
good.
experiment for you. And nobody's done that. It's so bloody easy to do it, and anybody can do it. You know, forget the curvature. It's been proved. There is no bloody curvature. You know, this is something you can do for yourself. You know, make a little video of it and put it on YouTube. You know,
yeah, we need somebody from we need somebody from one of the islands where the sun passes over the whole thing, like Key West, where you can go see the sunrise and the sunset by going one end of the beach to the other, or one end of the island to the other end of the island, and you know, mark out exactly which compass direction the sun comes up at these different times of the year, and make a log of it. I mean,
it's not going to change.
I've already been into this. You and I both have almost, you over a year, me almost a year, and you know, there's people living all over the earth. It could be contributing information, and we've been fighting and infighting and more fighting and calling each other names, and not cooperating. And they know, the infamous they know that that's going to happen and has happened, and they're part of the reason why it did happen, because there's been one shill caller after another shill caller coming into the movement and disrupting everything. And so when I first got involved in this, everybody was hunky-dory and kumbaya, and now it's like it's come to a standstill because everybody's afraid to push back against the commonly accepted AE map model. And we've got a long way to go, but we're on our way if we'll just all agree that it's time to either put up or shut up. And like Lawrence has said, and I've said it too, debunk what we've said, debunk what we've shown, and we'll shut up. Promise. We both have lives and better things to do. This show could be a heck of a lot more fun and a lot more entertaining, and we could be having themed events every few weeks with, ladies with red hair, or Flatty Awards, or whatever else themed ideas we could come up with. We're not into that. We've never been into that. This has always been a serious show. So that's all I.
And one last thing, there's people who are flat earthers who live in the Scandinavian countries, Sweden and Finland. I don't know if that's Scandinavia, but in the northern hemispheres where it's like, I don't know, getting on towards 60 degrees north, and you're close to having a midnight sun there. Get out and take some map some compass readings on the sun, because the sun should be nearly doing a full 360 if you get in a midnight sun. And you should be able to show the sun in the sky, north, south, east, and west, every direction. But you won't be able to, because it don't do that. And it's so easy to prove. Why don't you do that? If you're a flat earther and you live in Sweden, get out there and do it.
Well, it's the same thing that we're having the same problem with a lot of things. People spend all their time looking at their computer screen and not actually getting outside and doing real-time experiments and verifying things. And so it's time to turn off the computer and become one with your flat Earth and try to help your fellow flat earther by starting to accumulate some data that the rest of us can use, because we are finding that some of the data is wrong and cannot be relied upon to make maps, models, and reality out of. So, okay.
Are we done, Laurie?
Yeah, say goodbye, Lawrence.
Yes, goodbye, folks. Sorry for the mess up, but somebody somewhere didn't want us to talk tonight, so they dropped a big spanner in the works and threw us off our court, you know. Took us off our stroke, didn't they, Laurie?
Yeah. Okay. Thanks, everybody, for joining us. And we'll put this link up so that you could start over from the beginning, those of you who lost the link that we had earlier. So we'll see you next week on Sunday, and we'll talk less about maps and more about other phenomenon that about the flat Earth. And I'm sure you're all clapping at this point. So good night, everybody.
Yes, good evening and good night.